So, good afternoon, or is it already good evening? At my place, it's dark already. Welcome, everybody, to this last time slot of the DDD Developer Day. I have a bit of, housekeeping to do. You are aware of the code of conduct, and everybody's following that, I think. You are aware that we are giving for a charity, which is the National Museum of Computing. So, if you consider give me a little money there. Also, we thank our sponsors who give for this charity instead of giving out lunch or paying for the rooms. Thanks to all of these sponsors. Get in touch with them. They have products that might be of interest to you. Okay. And of course, yeah, tweet about it with the hashtag, and there's the Developer Day handler. Enjoy your day. Well, I hope you did that already. So let's get started here. Welcome to 50 Ways to Show Your Data. My name is Thomas Hütter, and well, there's an umlaut in this name, so you can tell I'm from a German-speaking country. I have a degree in business matters, but I've been an application developer for most of my professional life. Also did a bit of a consultant. I'm accidental DBA and stuff like that. I mostly speak at SQL-related events around Europe, but I have also been to the DDD North, which was actually the last event before this shitty pandemic broke out. That was in person. So I mean, wear the shirt of that proudly. Right. So here's the agenda. What's the fuss about this R language? Well, thank you for leaving your comfort zone. As I've learned, most of you are .NET developers of one kind or another, so the R language is completely something different. And it has some parts to it, like the flow of data when doing a data science or analysis project. And what I'm be talking about today is mostly graphics, visualizations, something like that. One caveat here, I don't have a continuous story to tell from A to Z. This is more of a collection of fancy graphics you can do in R, which either I have found at one point in time and thought that's interesting and I found out how to do it, or someone came up to me at one of my other talks and asked how to do this and that graphics. So I collected some of them and that's what we're going to do today. Very briefly, what's the fuss about the R language? Well, the R language was founded about 27 years ago by two gentlemen from New Zealand as a successor to the S language. It's used for statistical computing, analysis, visualization, all that stuff, mostly by the folks that call themselves data scientists. So the most sexy profession of the moment. I don't know if that's true. It's an open source GNU project. It's maintained by a foundation. You can run it on macOS, on Linux, and on Windows. And it is one of the key success factors. It's extensible to so-called YUM packages, and there are about 60,800 of them available for download. Think of them as small extension libraries that everyone who uses the R language can create and give them to the community for others to use. And I have one example of that later on in my demos. There's been commercial support also. There's been the company called Revolution Analytics who were acquired by Microsoft. So since a couple of years, Microsoft also provides R in their SQL Server environment, in their Azure environment. There's the R server and so on. There's you can use R in Power BI. There's Azure Machine Learning. There's a whole data science virtual machine you can spin up in Azure. So that's very useful. There are a dozen of IDEs. You will see the RStudio IDE, which is the de facto standard. There used to be a thing called MSR tools for Visual Studio, but they deprecated that from the 2019 version. So basically, what that's saying is use RStudio. Okay. Right, so a typical data analysis project, it may look like this, and this is taken from a book by Wickham and Grolemon, Hadley Wickham, one of the brightest minds in the R ecosystem. you probably follow this path most of the time. You import some data from somewhere, be it a flat file or from the interweb or whatever, from a database. You have to tidy and transform it to generate a visualization, to get an idea, an insight of what's inside your data. You may want to build a model in order to do something like prediction and so on, and you can take turns and improve your model again and visualize it and so on. That all goes to understand what's in your data, really, what's hidden, the insights you can get out of that. In the end, you want to communicate to internal or external customers, whoever, and the whole thing is within the bracket of programming in the R language. And then you got something like called the tidyverse, which is a way of handling those things. Also, there are a couple of tools, a couple of packages that make up the tidyverse. And the ggplot package, which I'm relating to in this talk, is one of them. So those packages together, they make it easy to accomplish all these tasks in a very concise manner. All right, digging in deeper to ggplot. Where the GG stands for Grammar of Graphics. That's a principle already coined by Leland Wilkinson in 2005, and that was a foundation for implementing this in R. And my simple approach to what is needed for a graph in R is as follows. That'll be the data first. So what do you want to show? Of course, you have to give it to the function call. Then you have something called aesthetic mappings that basically, which relations are there to show. So basically that boils down to what do you want on the x-axis, what do you want on the y-axis. Then you have the geometries, how you want to show it. So do you want a scatter plot, do you want a line graph or a bar chart or whatever. And then you have lots of extras, like you can play around with the axes, with scales, you can add a legend and labels it, do faceting and use different coordinate systems, colors, themes, you name it, it's possible. Okay. And yeah, that was the quick run through. We don't have an awful lot of time in 45 minutes. From now on, if you read the abstract, you know that it will not come up to 50 ways to show your data. It's more like 15 or so. And I listed them here. I'm not going to read all of them to you. I listed here what it's called. I listed, I stated in a sentence or two, what's it good for. And from now on, I'll switch over to my demo. Okay, here we go. So this is the RStudio environment. For those new to it, a brief run through. On the top left, we got a source code window. Of course, you can have several source files open. In the bottom, there's the so-called console, which is good for doing interactive stuff like this. You can call functions, and it gives you the result. And also, if you call some function calls from the source code, the result will appear down there. There's a terminal window for doing OS stuff. Okay, the jobs tab is relatively new. You can, if you have a long-running R script, you can start it as a job in the background and continue to work on other matters in the foreground. Okay. Up here we have the environment where all the variables will show up while we create them. We have a history function of the function calls. We have a connection tab for database connections. You can see that mostly I work with a SQL Server. And also relatively new is the tutorials tab up here. So you can start tutorials on R functions and RStudio and how it works from within the RStudio environment. Right here in the bottom, we got a multi-purpose sort of window. There's a small file explorer here. We got a window for the plots. We got a list of those packages. Those are the packages that are installed on my machine. We got a help window because every package comes with a help page or so. And of course, the basic R system and RStudio, they all have the help pages. And there's a viewer for more interactive stuff that doesn't go into the plot window. Okay, right. So I got one source file open, and that contains all my demos, and we can invoke this by line, by on the Mac it's Command Enter, on Windows it will be Control Enter probably. So I do it like this, and you see down here it gives us some response, some messages while we go along. I'll load the popular tidyverse packages, which are listed down here, and I have some special packages I have to use, which I'll load now. And then we get going with one of my favorite data sets, which is this one. I'll just pull that into this screen here, which comes from the internet. There's a site called Formula 1 DE, it's a German site. It has all the results of the Formula 1 racing series. And we are here in the 2016 season. Why choose 2016? Well, there was a German guy at the top. Enough reason for me. You got all the races and all the points for all the drivers in here. And we got lots of stuff around it, like buttons and menus and advertising. So, but we're only interested in this part of the site. So we can read this via read HTML function. That will extract that from the site. Let me see. And into a first variable, I call it F1. And you see down here, we have all the points, we have all the drivers and all that sort of stuff. It's not very complete because it lacks column names, and there's these dashes here that I can't really calculate with. So I'll do a bit more of data mangling here, like, let me see, adding some column names. I'll format it properly. I also, at this step, I'll filter it down to the best 9 drivers and do some other magic, which makes it look like this. Now, I got column names like race 1, race 2, and so on. We got the names here, we got all the points down here, and there's proper zeros where there's 0 points, and so on. Still, that's not good enough for the tidyverse. The tidyverse packages like to have the data in the so-called long format, which looks like this. Let me get to the top here. So I've got all the race in one column, I got the points in one column, and in one step I added the cumulative points and average points, and that's a proper format the tidyverse packages are satisfied with. So time to call our first plot. So that's the ggplot, it's called the function call, and we can develop it like this as I wrote in the slide, step by step. That's the data. Our data is now in the F1 long, and that down here is a valid graph. There's not much in it because, yeah, we have to state what should it look like. So I go on to say I want the races on the x-axis and the points on the y-axis. Well, that already succeeded here. We got points from 0 to 25 and the races. But where's the real data? Well, we didn't state any geometry yet. So we can do like that, a points graph or a line graph, which of course is still not what you expect to see, but this may come close to it, okay? So we see for the 9 best drivers of the season how their points evolve over the season, color coded here. Very nice. So that was the cumulative points. If we look at that, that was the average points. Someone started right on top and went like that. Or if you want to, let me see, if you want to see the whole picture, it would look like this. It would look like this. So that is for every race, every point the 9 drivers made, and you see it's rather cluttered, so you can't get really any information out of this. So we do a little magic here, like that, which is called a so-called facet wrap. So that makes the graph split up into the 9 subgraphs for each driver, one graph of his own, and still, because they have auxiliary lines, they are comparable. So you can see like this race 06, Bottas was down there 0 points, and even Rosberg was no good, and Lewis Hamilton won that one. or here where both Mercedeses came in at 0 points, and usually I have Dutch folks shouting, yeah, but that was Max Verstappen won. Right, there you go. One victory for Max Verstappen, but that was an outlier, I would say. Okay. So facet wrap, the first thing to get you started a little bit. We can make this look a little bit more statistic-like. So usually I would ask the audience, do you know how these graphs are called? So at the moment that's not really feasible. So those are so-called box plots. And what do box plots show us? Well, they show statistical measures. The line in the middle here, that's the so-called median. That tells us that in 50% of the cases, this driver had, what is it, 18 points or something, 18 points or less, and in 50% he had more than 80 points. The top and the bottom of the boxes, oh, let's get over to here. Top and bottom of the boxes are the 25% line. So Mr. Ricardo, in 25% of the cases, or of the races rather, he had 10 points or less, 25%. And the top is the 75% line. So in 75%, he scored like 15 points or less. Then there are some lines, you can look up how they are defined. And if anything is outside these lines, they get plotted on their own, and those are called the real outliers. So if you compare Rosberg and Hamilton, both graphs look totally equal. They are equal. So still Rosberg won. So what's the difference here? Why is it not visible? Well, I show you the statistical summary, because both of them have a minimum of 0, a first quartile of 15. They have the median at 18.0 and a maximum of 25. The only difference in the statistical values is the mean. Rosberg has 18.33 and Hamilton has 18.1, but that value is not part of this graphic. So be aware, that's lying with statistics. It's not part of the graphic, so it doesn't show here what the difference is. Okay, one more graph where it is a bit clearer to see. I'll zoom into this one. Well, if you look at Hülkenberg, you know why those things are called violin graphs or violin visualizations. They also represent the distribution of the points. So if you look up here, you see that the Rosberg graph at the 20-point line, take this one, it's wider than the Hamilton graph, which means Rosberg scored more of the high point things than Hamilton did. Whereas at the bottom, I hope that is really visible, the Hamilton graph is wider at the 0-point line than Rosberg, which means he had more 0-point scores than Rosberg had. And so because the one had more top scorers, he won that season. Okay, let me get back here. Sometimes I have to clear these areas so my memory doesn't get cluttered. Okay, as I said, it's a collection, so we're jumping a bit from one data set to the other. Built-in data set in R is the MPG, which has car data, the different car models, and with their motor or engine data, and most important, the mileage, city and highway mileage. So I can do a bit of data mangling here and calculate the average mileage per make. And then I can go and visualize that, for instance. And if you do a bar chart, that's not very attractive, I think, and it's even distorting for your eyes if you put that on the screen. And if you want to print that, you need lots of ink, and it doesn't get much better doing color. So what can you do? I don't remember who asked me that. The lollipop charts, which look like this. So that it's a nicer way of doing it, and also you don't need too much screen area to represent those. You can either, well, that was handmade because you can combine a point with a so-called segment, or there's it looks just the same. There's a geometry called the geom lollipop. You can have that in one go, okay? Easy peasy. Yeah, we stay with the MPG data just a little more. We have a scatter plot here, right? Scatter plot from the cars of the 2000s. We have the city mileage over the engine displacement, and as a third dimension colored here, we have the cylinders. So, and there's some 5-cylinder models in here. Can you spot very easily where they are? Well, yeah, here. But to make that a bit more visible, and well, you might call it a bit of optical clustering. You can do something like that, encircle the area, and that takes the same color as the data point. So you can see, yeah, the shape is something you can't influence very much, but you can see the 5 cylinders are all in here, right? The 4 cylinders are within this boundary, and so on. 6 cylinders, 8 cylinders. There's a second data set concerning car data, which is the cars of 1974. And that was a comparison I found rather interesting. If you look at the 4-cylinder models, they come in close to 35 mpg here. In the year 2000, not much did change there. The top model also does around 35 miles per gallon here. So that was like 26 years in between, and not much has changed in terms of the better values there. So I have yet to find a data set that has current cars and then compare it to that, but I found that rather interesting, wouldn't you say? Okay, let's move on, clear it up. And yeah. Again, the MPG data set, I plotted highway to city mileage. And when I tell you those are 234 different models in there, let's see, yes, 234. Well, you don't need to count them all by one. You can spot that those are not 235 points. So what happened? Well, what happened is that they calculate the mileage in integer numbers. So you get like here 18, 18, 18, 18. That's not very precise, and that means that several of these points are plotted several times. So like here, these ones are single occurrences, but that one done here. So to make that a bit more visible, yeah, we can do something like this, and let me zoom this out for you. Here, where we had 1 point in the last one, we add a bit of jitter to the points, and you can see there's actually 4 or 5 of them here. Those are really single points, that's okay, but here there were 5 points at exactly the same position. And like also in between here, it gets clearer where all the points are. Yeah? That's one. There are several. So you have either this possibility, but that's a trade-off between the precision and the whole picture. Of course, those are not at the precise position where the values are, but you see that there are several of them. One more possibility is to vary the diameter. So if you see those are single points, they're very small. And there, where you have 5 points at one position, the diameter grows. And also here and there. So that's to make clearer that there's more than 1 point in there. Okay. Next up, still the car data set. Yeah, if you want to label your points according to which model it concerns, what happens is that your text label runs over the point. Sometimes if the points are close to each other, the texts run into each other. That's not very good. So what can you do about it? We have a function called the repel function. We can integrate that into the graphic. Let me see. So that the text stays clear of the respective points. And where do we have it? Yeah, like here. If those texts would run to each other, it gets a bit of a distance, and there's a small line that points to the point, which is related to this label. Also, you can integrate the third dimension here. Come on. By using background colors, so you still have the labels, stay away from the points, you have the little auxiliary lines, and by adding colors you can add the third dimension of showing which cylinder models, how many cylinders those models have. Okay. All right. So for the sake of time, I'm going to leave away the rich lines. You can still follow up if you download my demo code. Tree maps. If you're like me, tree map is probably something that surprises you, because I would have thought it's that thing with branches and branches and branches. No, that's a dendrogram, and a tree map is actually. Let me get the Europe one. It's actually this, where the measures are represented by the size of the area they are plotted in. So those are cell phone subscriptions per country within Europe, and you see the bigger the area that that country here represents, the more cell phone subscriptions are in there. And you can do even groups of measures, like here, that's Eastern Europe and so on. And something that surprises me time and time again, the UK is summed up in Northern Europe here. Is that a usual thing to do? I'm not sure. I would have put it to Western Europe probably. Okay, well, very easy. Then, yeah, one of my favorite examples is the waterfalls. And there I had, first I found the package Waterfalls with an S. And I thought out an example which I want to show. And what happened was it gave me this graph. Let me pull that into here. It gave me this graph. I'm going to explain the top area later, but it had this white area down here. And there was no data there. I thought that was not supposed to be there. So I thought that's wrong, but I couldn't get rid of it. So I found out who had developed that package, and I wrote to him. It was like beginning of January or something like that. And I wrote to him. It was a guy called Huge Personage, and I sent him my example. I said, hey, that big white area, I think it shouldn't be there. Maybe you can look into it. And it was by the end of January, actually, there was a new version of the package on the Grand Mirror to download. And then I used that package, and it gave me this one. So there's a small white area here, but the big useless area is gone. So that's one example how the community works greatly and gives back their products, because that was a package made by this guy. It was not from a company. It was one developer who thought it was it could be needed by others, and just like that, he merged out the error for me. So what do they do? But waterfall, very simple. You have some measures here, like inventory of some item. So you start with an inventory of 100, and it develops from the baseline. So the baseline is your 100. From there it goes. Yeah, you have to scrap 20 items, and you have a baseline down here. Then you purchase some, you produce some, and the baseline gets up here. From there you sell some, so it goes down again, and so on and so on. Very nice to see how it goes up and down. And the last one there is calculated automatically. That's your total of 210 at the end of this period. And just to show you what the other package was like, which I found while I was waiting for the fix, actually. yeah, by default it looks like that. I found that not so appealing, not so versatile, but you have different possibilities of realizing things and all. Okay. All right, so we have some correlation upcoming. Also here we got two different packages, and excuse me, that's one of the occasions where I like the non-ggplot package better than the other one. We are still, yes, we're still using the cars data set. It has, I don't know, 30 odd models of cars and all numeric measures here, like number of cylinders, the engine displacement, like horsepowers, and so on. And what you can do with numeric measures, you can calculate a correlation. So those are the correlation coefficients for all the measures. Now, what does a correlation say? It can range from +1 to -1. If it's positive, then a rise of one measure can be explained by a rise of the other measure. Like, what have we? Let me see, horsepower and the horsepower and engine displacement. Yeah, like here, engine displacement and horsepower have a positive correlation of 0.79. So usually when you have more engine displacement, you have more horsepowers. Basically, that's what it's saying. Okay. But also you have between the mileage here, the MPG, and the horsepowers, you have a negative correlation. That probably means the more horsepower you drive, the worse your mileage gets. And so you can go about and visualize that. So the ggplot version of the correlation plot, it looks like that. That was not very much to my liking, so I use the other one. That is more appealing, and you can spot from visual properties how the correlation goes. Because if it's blue, it's positive. If it's red, it's negative, right? The darker it is, the closer it is to the plus and -1. So dark blue, dark red. And also they have here, the fuller the circle is, or the bigger the diameter, the closer it's to 1. So like the diagonal line, of course, that's all 1, so that's a full circle. And if we go here, the value is closer to 0. I go for the next one, and maybe it gets clear. Let me see. Okay, now that's the square one. I have some more of those. Like this, you have, yeah, you can spare out the diagonal line because that's always the same. You can even plot the values, but I go for the full picture, like this. And you got everything in one graph here. So if it's a sharp line, it's 1 or -1, right? If the closer it gets to 0, the bigger the circle gets. And it is blue is positive, like up here, and red is negative. But also, if it goes from bottom left to top right, it's a positive slope. And if it goes from top left to bottom right, it's a negative slope. And you got the numbers printed in here. So that is everything you can get in one graph. If it's useful, I'll leave it up to you to decide, okay? No, keep it. Okay, for something completely different, marginal plots. I have a random graph here, but that might be, I don't know, sensor measure values or whatever plotted y over x. And to help you to get a picture where the action is happening in this graph, where to look at, you can do something called marginal plots. So you can have a density curve which shows you that, well, in the x direction there's a maximum here, so the action is somewhere between there and there. And even in the y direction, you got 2 maxima here, which I wouldn't have spotted from first sight, but you see that one is here and one is there. You can have the histogram, where you see, yeah, of course it goes up here, but there you can see that there's a drop here in, so around that line there's not much going on. And you can have one of my favorites, the box plot, which we saw before, where you even have the median, where you know that, well, from this line 50% is left of that line, 50% of the points is right of that line, and also here the 50% line is a bit lower there. Okay, and then you got like outliers like these two. There's one outlier, and that's the other one, and there's one outlier in the strictest sense of the word. Okay. All right, next up, yeah, one other of my favorites. We'll stay with that car data, and I cut it down to 5 models and 8 of the measures, like MPG, cylinders, displacement, and so on. And for each of the measures, I normalized the values so that the biggest one would be transformed to a 1, and the smallest one to a 0. And then what you can do is this here, the radar plots. Check it out. Isn't it beautiful? So there you have, okay, 5 cars compared to each other with 8 measures. I wouldn't put much more of those into this graph, of course. But then you can go about 2 ways. You can either say, well, Ford Pantera is yellow line, so let's see how the Ford Pantera does. So it's top in engine displacement. That's the 100% line here. It's, well, second in horsepower, it's top in whatever that is, the axle ratio or so. It's the second heaviest, of course. Yeah, it's the top runner for the quarter mile. Seconds per quarter mile, of course. The lower the time, the better it is. It's somewhere in the middle. Yeah, the number of carburetors, you see they don't even have engine ejection. You have carburetors here. And yeah, of course, the MPG value is quite low here, right? Or you can go and say, well, let's see, maybe the display, or let's take the horsepower. You can start from here and say, well, top horsepower, that's the green one, Maserati. Second doing in the horsepower, that would be the Ford. Third is a Ferrari. And then down here, there's not much difference between the Volvo and the Lotus, right? So optically, I find it very beautiful. You can go around and then analyze it in different ways, but of course, it's not for big data sets to use. Okay. Yeah, important everyday maps. That's something I should. I have to prepare just a little bit. That's the data from a small German town called Kleve. They publish data of public car parks with their capacity and the value, how much is taken of that, and coordinates. So what I can do here is plot a map, and because they give the coordinates, I can just plot those points into the map. Wherever there's a circle, there's a public car park. You see, the bigger circle is, the more free places there are. And it even says, well, if it's green, it's open. If there were red ones, they'd be closed. And there's one that's blue. Somehow there's a disturbance there. I don't know if it's closed or it doesn't have proper data or something like that. That's because they give the coordinates in the same system as the map has the coordinates. I can just go and plot it into the map. All right. Yes, I have one. I hope that runs a bit faster here. That used to take quite some time. An animated plot. I have cell phone data again for Europe. And I'm going to animate that. It takes about half a minute to render, so bear with me. Come on. Yeah, and watch it. It comes in the view pane. So you see the the years run through, and while the years run through, it develops the graphic in the chart here, in the map. So where it's bright, there are no subscriptions, and the darker it gets, the more cell phone subscriptions are there. So if you see it start from 1990, the Nordics are first, then comes the rest of Western Europe, and then the eastern parts. So that will keep on running forever, so I'll stop that for now. But you can have animated charts here, animated maps. Okay, something to cheer you up in the middle. Anybody seen those before? There's a guy called, I don't know what his first name was, guy Chanov. He invented those Chanov faces as part of a graphic. So actually it's well-known type of graphic. So you can add an additional dimension here. Again, I have like mileage over displacement and the sinners in the color, and I have here where the mileage is low, it's a frowning face, and where the mileage is good, it's a smiling face, like up here. That's not for every occasion, of course, but just in between. So I don't know how we're doing on time. We started a bit late. Let me see. Okay, something useful here. I would like to show you again one of the mileage. Well, never mind. And let's say you're interested in the 6-cylinder data of this one. So what you can do here is to do called facet zoom, which then looks like this. It takes the 6-cylinder data and spreads it over the whole width of your graphic, and has then all the 6-cylinder data in a bigger area. So you can do that in the X direction as well as the Y direction, and I think you can even have both, but you'll need a real big screen to make sense of that. Okay. Right, so I'll leave out those themes. You can have themes, make it look like a Wall Street Journal publication. You can have fonts and stuff like that. And let me see. Okay, we're almost at the end. I'll give you one more plot, which is this one. It goes also in the viewer pane, because what happens here is this graph is interactive. So you can point the mouse at the point, and it gives you a tooltip of which model lies behind that data point. Like here's a Nissan, there's a Nissan, there's a Ford Mustang, and so on. And you can have different versions of that one. You can even make those points clickable and then fulfill some action like opening a web page or pull in additional information and so on. Okay, so with that I'm through. Let me get back to my presentation here. So there are all those fancy graphs lined up, and with the explanation I'll leave that for you. And let me see. I hope I could give you an impression of what is possible with R in terms of analysis and especially in terms of visualizations. Yeah, and those graphics can be constructed if you watch along in a very concise manner. It's always the ggplot. It's always the graphics. It's always the aesthetics and the geometry, and then whatever you need, colors, themes, and so on. Yeah, don't overdo it. Don't overload your visualizations. Be careful with the number of choice of your colors and shapes. Probably you saw that even in the first graphics of the Formula One, there was only 9 drivers, but if you put it all in one, it's a mess. So you have to be very careful how much you want to show. Also, the radar graph, yeah, that was only 5 cars, and much more doesn't make sense there. Yeah, well, consider where the occasions those channel faces, of course, are not suitable for every audience. No? If you want to take that out to your C-level superiors, maybe don't use them channel faces, right? So there's some credits and resources. I was really inspired by the top 50 ggplot visualizations, and also the list and the reference, of course. That's all stuff you can read online. There's a graphics cookbook by Winston Chang by O'Reilly. That's on paper. I still prefer my books on paper. If you want to dig into a little bit more alpha data science by Wickham Gronemon, that's on paper as well as online. So I would recommend, maybe if you have it installed and you want to get going, start with that one here. You can read that online. Yeah, credits to the folks I took my sample data from. And yeah, then we are here. This file and the demo script will be available from there. And I'll tweet that around also. And if you would like, you can stay in contact with me via my social media. Yeah, and so I thank you for your interest, your time. If you want to keep in touch, I'll be delighted.